There we go. Well, good evening, everyone. My name is James Skillicorn. I've been a member of Rewilding Linfield for between 2.5 and 3 years. I live in Haywards Heath. I've always been fascinated by kind of like protecting the environment. If I had a specialist subject, it would be worms and insects, but everything fits together. So tonight is going to be a very good night. Now, Rewilding Linfield, thank you for coming to the the March Climate meeting. Rewilding Linfield, we're a community group, and we hope to raise awareness and encourage local awareness for climate and ecological crisis, and we hope to encourage local and personal and collective action on this matter. We've been holding climate cafes on Zoom for a good while now, since lockdown began, on a wide variety of subjects. And if you'd like to hear more about them, do look at our Facebook page. The Facebook page is really terrific because there are all sorts of links, and it's a good place. If you want to ask any questions or find out about stuff, the links will take you all over the place. The rough timing now on this meeting is about until 8:45. The room will remain open until about 9, and the recording will be available on Facebook. So that's probably enough from me. It's my pleasure now to introduce Dr. Tony Whitbread, who's president of the Sussex Wildlife Trust. And I'm going to let Tony say more about himself because he probably knows more than I do. So over to you, Tony.
Great, thanks very much indeed, James, and thanks for inviting me along here this evening to have a bit of a chat. Yes, my background is in Sussex Wildlife Trust. I worked for them for 27 years or so, but actually my interest, my heartland, as it were, is actually woodland ecology. So I'm very interested in woods, trees, woods, woodland ecosystems, and so on. So it was great to be able to it's great to be able to come here and talk to you a little bit about, well, I've called it Trees for Life, or the life of trees, just to talk a little bit around the subject of trees and how valuable they are to us. What I'd like to do now is just share my screen, make sure you can see it all. Hang on a second, I started at the wrong place. There we go, Trees for Life. Okay, I'm going to talk about Trees for Life for a little while. And so I was thinking about this. I was thinking, well, how do I frame this? How do I talk about the whole subject of trees and life and how they're important to us? So I was thinking, well, there's a series of things we can actually go through. There's a series of reasons why trees and woodlands are valuable to us. And I'll talk through this, I think, through the evening. So woodlands as places that are special for wildlife. We can talk about that. But also woodlands are a history book as well. They form a network of nature, so they're valuable for that in actually creating the landscapes that we live in. And in the second half, because I'm going to divide this in half, I'll talk a little bit about woodlands as they provide us with goods and services, and how actually our very existence is determined and supported by woodlands and trees. So that's the sort of frame I'm going to give it this afternoon. And if you have any questions, then just stick them in the chat, and we'll see if we can address them during the half-time mark. So let's look at, well, how do we figure when it comes to forest cover in Europe? Well, actually, if you look at the amount of forest cover, the greener, the more trees. You can see that we're very poorly wooded in this country. In fact, we're lowest apart from Ireland. Ireland has less woodland than we do, but apart from that, we are lowest in Europe. And this covers Russia as well, which is pretty well wooded. But if you look at Scotland there, actually a lot of those woodlands are modern forestry plantations. But you can see there, although we think of some of our countryside as being quite well wooded, in fact, it's far lower in woodland cover, far lower in tree cover than the vast majority of Europe. We're starting at a fairly low area. And if we think about forests, we think about forest cover, then we often think about this sort of landscape. This is the Bielaweja forest in Poland. It took me ages to learn how to pronounce that. The Bielaweja forest in Poland, which is thought to be one of our last relic, really primeval forests, where everything is in place. There's all the herbivores, there's all the carnivores, and of course all the trees and shrubs as well. You have this wonderful idea of what a natural forest probably looks like. But in this country, we've also got our own forests, which are pretty close to that. This is a site called Menz. This is a site called the Menz in West Sussex, one of the Wildlife Trust's nature reserves. And again, this is a nice old growth forest where the forest is left to get on with it by itself. So we can get a picture of what our trees look like in their kind of natural habitat, in the natural landscape. So this is, the context that I suppose I'm talking about today, trees for life. But let's think about woodlands as places that are there for special wildlife. We find a lot of our special wildlife in forests and woodland. So trees and their associated wildlife. And we can think about a lot of things that are familiar to us that we're going to find hopefully in the next few weeks as the spring flowers come out. I'm sure we're all looking forward to seeing bluebells and that yellow archangel and a lot of other flowers as well. And these are very much associated with our woodlands. These are woodland plants. Lesser celandine is found elsewhere as well, but also there's pignut in there, which is very much a woodland plant. So we have a lot of special plants, a lot of plants which are associated with woodland, indeed which are often associated with very old or ancient woodlands. This is wood sorrel. If you see wood sorrel, that leaf there actually tastes a bit like apple peel. So these are things that are familiar to us and where we can see some lovely special plants within our ancient woods. This is early purple orchid. I nearly said common spotted. It's early purple orchid, and we get it in a range of habitats, but it's very at home in our woodland glades and a woodland ride, for example. So you see nice common spotted early purple orchid. Daffodils. We've got some fantastic daffodil woods in Sussex. They seem to be in certain locations where there are just larger numbers of daffodils. They're just down the road from where I live. I'm in Dorrington in West Sussex. We have some very good daffodil woods there. And just down, on the west side of Sussex as well, in West Dean Woods, very well known for its daffodils. And this picture makes several points, so I just want to talk about this. Bluebells in the background there. This carpet of bluebells is very much something of Britain. People travel from all over the world to see our carpet of bluebells. And they form, as you've seen, continuous expanses of bluebells in our ancient woodlands. Even more so in the foreground here, we've got wood anemone. Now, wood anemone likes spring wet clay soil. Now, for people who live in Sussex, that describes Sussex really, doesn't it? But the other point about wood anemone is that it's a very slow colonizer. It's perhaps one of our best ancient woodland indicators. When you see carpets of bluebells, carpets of wood anemone, sometimes in spring it looks almost like snow. When you see that, you're in an ancient woodland. And an ancient woodland is a woodland that's been there for at least 400 years. That's almost a random cut-off point, though, because if it's been there that long, it's probably been there for a lot longer. So 400 years plus count as an ancient wood. Ancient woodlands have all sorts of plants which you don't get in recent woodlands, and you don't really get in other habitats either. So ancient woodlands are really valuable. So the trees that form this woodland cover, which provide perfect conditions, supporting plants that are slow to colonize and characteristic of woodlands, that describes habitats of things like bluebells and wood anemone. Lots of other plants as well. In fact, a lot of the plants that you think of as just woodland plants, the odds are that they're much more associated with ancient woodlands than they are with rather more new habitats. Ancient woodlands, by the way, could have been managed. In fact, almost certainly have been managed. It doesn't mean that there's never been anything happening there, but ancient woodland, one of our best, I suppose, one of our best ecological treasures. Fantastic. Okay. But if we think about our woodlands and we think about our trees, we think about where they live, we think of trees and where they live. But one point I want to get across really is that woodlands form communities, or communities of plants. So they don't just occur randomly, I suppose that's fairly obvious, but they do form identifiable communities. Now, if we think about Sussex landscape, this is a picture taken from, I don't know, somewhere near Midhurst, I think, looking out over the Weald of Sussex. Think about the Sussex landscape, then you get different sorts of woodland in different places. And as I say, it's not just the trees are different, but the whole community of plants is different. Let's think about on the Chalk Downs, the South Downs. We think about woodlands that form on the South Downs. Species like beech and ash and field maple, they tend to be the common species there. We get oak and other things as well, but yeah, beech, ash and maple, maybe white beam as well, maybe some rich shrubs like rich layer of shrubs, spindle, dogwood, those sorts of things, wayfaring tree. And in the ground flora, you get a lot of Dog's Mercury. So that mixture is a community of chalky landscapes. You then come down into the Weald of Sussex, and you're on very sticky clay soil, which are kind of neutral rather than alkaline. And in these sticky clay soils, that's where you get your oak wood, usually with hornbeam and chestnut, hazel, those sorts of things. You don't get so much wild maple, field maple. You don't get so much dog's mercury, but you do get these carpets of bluebells. These Wealden woodlands can look really spectacular because of their spring flowering plants. So that's where you find these wonderful mixtures of spring flowering plants. And you go up onto the Ashdown Forest and maybe up onto the Greensand Ridge around Midhurst, and you see a woodland type which is much more dominated by oak, yes, but lots of birch, a lot of birch. And you can probably picture it, oak and birch over a bracken ground flora. Maybe in the open areas you might see a little bit of heather or even bilberry. And that talks about a very kind of heathy woodland that you get on the sandstones of Sussex. Come off the sandstones, go down into the river valleys, and you'll get older woodlands. And again, very, very different. I think the point I'm making here is that woodlands form identifiable woodland communities with their own mixture of plants and animals. And that's actually what's really exciting, particularly in Sussex, because the geology is so clear. We know where the geology is. It's very clear to us. You can see the chalk, you can see the clay, you can see the sandstone, and that's reflected in the sort of tree and woodland communities that we get. But when it comes to trees being important for wildlife, the oak stands out amongst all of them. Many of you probably know that oak supports more species of wildlife than any other tree in Britain. It's a really rich tree for supporting wildlife. Insects, lichens, liverworts and mosses, all those sorts of things are on oak trees. You get more of that than anything else. I don't know what all these species are. I know some of them, one or two. Huge ranges of insects are supported by oak trees. Oak trees support a very big biodiversity. Our other native trees support quite a lot. I think willows come second, something like that. We get all this biodiversity supported by oak trees. And oak trees, well, all trees actually, but particularly oak trees, they form kind of special conditions. It's not just a kind of standing tree, it's all the other things that are associated with it. So you get rot hollows, fallen trees, old branches, you get holes that woodpeckers make use of, you get great buttresses which are hollow inside, you get all sorts of incrustations of lichen and moss and liverwort and things like that. That all creates diversity, all a kind of rich structure which is living space for different wildlife. So trees, oak trees in particular, are an amazing resource for all sorts of wildlife, just as a substrate in themselves, as well as the woodland community they support. Saproxylic fauna, I love that term, saproxylic. It means wood-eating. So wood-eating insects, wood-eating fauna. What sort of wood-eating insects do we actually have on oak trees? Well, there are 700 beetles that live in oak trees. That's nearly a fifth of our entire beetle population. We have a lot of beetles in Britain. 730 true flies. So 730 flies live in woodland, live in trees. Lots of bees and wasps, often little tiny things you can barely see. Bees, ants and wasps. A lot of moths. There are some moths which are completely associated with the oak tree. There's one, the oak portrait moth, which basically supports the whole ecosystem. For example, blue tits, they actually arrange their nests so that when the young emerge, when the young come out of the egg, all these oak portrix moths are completely covering the oak trees, so the blue tits can take those caterpillars and feed them to their young. So the blue tits align their breeding with the emergence of these moths. Did you know, for example, that one blue tit's nest can actually eat 10,000 portrix moth caterpillars in one season? Imagine if we didn't have any blue tits, how many moth caterpillars there'd be. That's interesting. And loads of other things as well. So you get a large biodiversity, a large fauna actually living on oak trees. Oh, actually, okay, so if we want to improve our tree habitat, what do we do? Well, we can actually just walk away and leave things. We can actually take off the agriculture, take off all the disturbance that we might otherwise put onto the landscape, and just watch what happens. And this is an aerial photograph taken from over the Knepp Estate in West Sussex, a rewilding project. None of those trees were planted. They all came in completely automatically, completely by natural processes, and that's only 15 years. In 15 years, you can see all this woodland just rushes back into an area once you stop the agriculture. A real kind of verdant growth of new trees once we actually allow nature to get on with it. And you're probably familiar with this. If you have an area of grassland, actually shrubs take over, trees and shrubs take over. Eventually the shrubs close over. And eventually you get a closed canopy forest. So the idea of kind of shrub and tree growth, starting small, ending up, then you get your thicket stage and you end up with a closed canopy forest. Now, some of you may know about this process of succession, as it's called, and it ends up with so-called climax forest. That's a nice model, a nice idea that you're getting this enriching of the landscape as trees and shrubs grow and eventually form this closed canopy forest. I'm going to come back to this later. Okay, so if it's not bust, why are we trying to fix it? If we leave everything alone and it all just goes down to forest, then why do we manage nature? Why do we do that? Well, you've got a bit of a problem, haven't you? Because actually, closed canopy forests support far less than half our native trees, our native wildlife of all sorts. And habitats like this is a chalk grassland with orchids on it, pyramid orchids. Habitats like this are specific habitats. They're not just on the way to becoming a woodland. They're not just a weed community which hasn't quite made it yet. These are habitats in their own right, with their own history and their own flora and fauna. So you have all these sorts of different habitats, which are certainly not on the way to becoming a woodland. Here we have wetland plants. You don't get these wetland plants, they're certainly not flowering in dense woodland. So you have this problem. Where would all these animals live if that model of getting to climax forest was actually the only thing that happened? All these birds, they actually require open habitat and considerable expanses of open habitat as well. Here we have some heathland examples: Dartford warbler, silver-studded butterfly, woodlark, and the other one, what's it called? Stone chat. These are all heathland species. And if you didn't have any heathland, you wouldn't have any heathland species. It can't just be a modern human artifact to have heathland, because these species wouldn't have evolved if that was the case. These are heathland species that require heathland. So the idea that it's just woodland, trees, and sometimes we over-appreciate trees and think anything without a tree on it is a damaged habitat. That isn't the case. Okay, so with this section, I think I'm saying there's actually a lot more to woods than just trees. Trees are vital. They have all sorts of functions and support all sorts of wildlife, but there's more to woods than just trees. There's actually more to forests than just woods. See what I mean? Woods you could call as the wooded part of a forest, but forests are much more diverse than that. They have open and closed areas, for example, different habitats within. There's actually more ecosystems than just forests. There's wetlands, there's grasslands, there's all sorts of other areas, heathland. There's more ecosystems than just forests. So we don't just create forests. And also, slightly more controversially, there's more to ecosystems than just pretty places to go and see wildlife. Wildlife's important, but there's more to it than just being somewhere where you can go and see wildlife. It's not just a kind of visitor experience. It's a lovely visitor experience, but there's far more to it than just places where you get to see wildlife. The next part of what I was wanting to talk about is the idea that woodlands are also a history book. You can actually go into woodlands and you can read signs of past management. Here we see a coppice stall, a chestnut coppice stall. For those of you who know this sort of thing, the coppice stall is the bit at the base from which everything sprouts. And you can see from this example, the individual sprout is probably 20-ish years old, which means it's probably been cut every 20 years. But the stall itself is actually quite old. It's very wide. Now, this is obvious, but you can go into these woods and you can see coppice stalls. Maybe they haven't been coppiced, and you can therefore interpret what happened in that wood for a very long period. You can read signs of management in the structure of a wood. For other examples, the shapes of trees. The left-hand one there, look at that oak tree in the middle. That's that shape. It's not a narrow crown. It's grown up and then it's spread out. And it did that because it grew over the layer of coppice. It grew over the layer of shrubs that were cut. So it grows up and then it spreads out. Look again, it's actually got some branches lower down that are dying. And that says there's been several phases here. And the last coppice layer probably grew much taller than the early coppice layers because it shaded out the lower branches. You get an idea of how past management has been influenced has influenced the shape of what you're seeing today. Look at the one in the bottom right-hand corner there, in a dense woodland today. And you think it might always have been like that. But no, this tree is a spreading tree. It grew right out in the open, probably a very long time ago, because now the lower branches are dying because they're overshadowed. So all the trees around it have pulled off those lower branches. The tree's still very healthy. It's just reshaped itself. You can see history. It was grown in the open and then trees spread around it. Sometimes you can get an idea of phases of woodland simply by the shapes of the trees. You can see things like parkland, where open pasture woodland, where big old trees have grown in the open and got all their characteristics because they're in the open. And then you can see dense woodland, where the crowns are much more narrow. They go straight up to the light, and that's how the woods actually form. Sometimes you can see something that looks like a dense woodland, but it's got an open spreading tree in it. So you can read the history a long time ago was more open. And you can see this sort of thing, and you go around woodlands today. It is a history book that's there for the reading. You can also look at the long-term history of woodlands through their pollen, the pollen that they leave in soil. This has been done quite a lot to actually work out what our long-term history was. Now, this diagram, I won't dwell on it too much, it's kind of the wrong way round. So the modern period is on the left and the Ice Age is on the right. So it goes because it goes that way round. And you can look at this and you can see, well, just after the Ice Age, there was lots of oak at the bottom there. And then more recently, you can see there's lots of oak, quercus, about halfway up, and right at the top, lots of hazel. Okay, so you get the idea of birch woodland, maybe elm woodland, oak woodland, alder, and hazel. So you get a picture of the sort of woodland that was there. But actually, it's far more complicated than that. You look at that and you might think, well, that's what the forest was. Well, you've got a problem, because actually things like hazel, if they grow in dense woodland, they eventually die out. I've seen nature reserves where, because of the dense canopy, we end up losing hazel. And if you've got a dense woodland, the last thing hazel does is flower. It doesn't produce any pollen. This diagram here is actually from pollen. So all that hazel was there throughout history, large amounts of it producing pollen. It wouldn't have done that because it couldn't live in dense woodland, and it certainly couldn't flower, and it certainly couldn't produce any pollen. So you have a problem. So it means that this hazel woodland wasn't a dense woodland. The same is true with oak. Oak doesn't regenerate in woodlands like this. Oak actually regenerates in grassland. So one interesting thing about this history is that trees are in a much more complex relationship with their landscape than we think. And it's probably much more opening, much more various, much more open canopy, much more varied than we imagined, right deep into prehistory. Not just now, not just today because of management, but right deep into history. So the idea of this dense forest where a red squirrel could jump off tree to tree from Land's End to John O'Groats is nonsense. That couldn't possibly happen. And we get, again, you get all these different species which live on trees, and you think, okay, so they live on trees, therefore it must have been forest. No, because these live on trees, and these species require trees that grow in the open. They need lots of air around them. And these species also, in parts of their life cycle, need nectar sources. Nectar sources from flowers that don't grow in dense woodland. So again, it all talks about much more complexity in our environment than simply trees only live in woods. Okay, so that's getting us so far. But the other thought I had when I was trying to think about, well, what's the value of trees to life is, well, woodlands and trees and forests, they form a network for us. They form a network in our entire landscape. You could think that actually, here's an example. That's the Barbastell bat on the top left-hand corner there. That's Ebano Common in the bottom right. So the Barbastell bat lives in Ebano Common. Barbastell bat is one of the rarest, probably the rarest bat in Europe. Very rare species. So if we look after that species, that's an important thing to do. Lives in Ebano Common, fantastic. Look after Ebano Common and you've looked after the bat. No, it's not true. It doesn't work, because actually it only roosts in Ebano Common. Ebano Common is one of our nature reserves, one of our most important woodlands in Sussex, and that's an important roost for Barbastell bat, along with lots of other bats. But actually, those bats, they commute all through the landscape. They require the entire landscape to be in good condition. Each of these little dots is an individual bat that's been radio tracked. In the middle here, here where they all cluster, that's Ebano Common. That's where they go to sleep during the day. But each individual bat then flies off out at night into forage areas to do its feeding, and then comes back at night. It comes back in the daytime. So maybe twice a night, it goes right out into the landscape and right back again. They can fly 30 miles in one night. And they require the landscape to be in good condition. They track along woodland edges and through little shores and hedgerows. So they require the whole landscape to be in good condition. That's what it looks like from the air. This is a little diagram of the big blue blob is where they roost, and the blue lines are the flight lines. The red lines are where the flight lines are broken. The Wildlife Trust actually tried to work not just within the nature reserve, but in the surrounding landscape to try to reconnect these flight lines. So again, trees in their wider landscape, often in belt, often in hedgerows, often in shores, as they're called in Sussex, they have a function with this particular bat species, enabling it to get into the wider landscape. Here's another aerial photograph of Ebony Common. I nearly pointed with my finger then, but there we go. That's Ebony Common, if you can see my cursor. And this area in the background here, we've now rewilded by encouraging the natural regeneration of trees. We've also worked with local landowners to put back in place hedgerows and shores in order to get those bats to be able to fly out into their wider landscape. And it's been amazingly successful. We did a survey in 1998 and again in 2008, and in that time, the bat population there had doubled, which previously I would have thought was impossible. You don't usually get results that clear. So it really shows that interconnectivity can be really, really important. This is just one example. The odds are that all of nature functions like this. And we can think about, well, what's the role of trees as special place, special things in the wider landscape? We can see our green and pleasant land here, but actually woods and shores and strips of hedgerow are pretty isolated. We can actually think about, can we reconstruct this landscape and make it more interconnected with trees and woods? Can we actually rewild some of these areas, look at regenerative agriculture, look at pasture woodlands, look at woodlands, look at belts of trees, and make it so that this whole landscape can function as kind of interconnected whole for the wildlife that it supports. And this has practical application. And in Sussex, there are district councils here. This is Horsham District. I believe Mid-Sussex is probably doing a similar sort of thing, looking at, well, how do we create a nature recovery network? These are some of the key sites in Horsham. In the middle here, we've got the NEP Rewilding project, and a lot of the green blob to the north, they're woodlands, trees and woodlands and strips of woodland, sometimes blue woodland. To the south, we've got the wetlands of Amberley and the grassland, the short grassland on the downs. Okay, so that's the special sites at the moment. That's looking after what we've got, which is the first priority. Next priority, though, is, well, how can we interconnect all these? How can we encourage natural regeneration? How can we do planting to link up some of these places to build a nature recovery network so that that interconnected landscape can once again work over the whole of our district, not just in individual little sites. That's my kind of idea on, we've got trees, form woodland, they form woodland communities, they form communities which have plants in them which are associated with ancient wood, which are slow to colonize. Trees support a large population of species that you simply wouldn't get if you didn't have the trees. And actually, if they form a network that nature can spread through. Also, woods provide a fantastic insight into how history played out on individual sites. That's my first half. I'm going to go on to talk about the benefits and services that woods provide just for the last little bit now. But I wondered, James, are there any questions so far?
First of all, you mentioned Ebony Common and you mentioned a Barbastel bat. Now, I've never heard of either of those. Whereabouts is this common? Right, yes, that's a good question. Unfortunately, I know some of these things too well, so I assume everybody else does. Yes, there's two woodlands that you really must visit right over in West Sussex near Whitbread Green, that sort of area. One of them is Ebony Common, so that, if you go directly north of Petworth for about 5 miles, it's actually right in the middle of the Weald. It's an old wooded common, so it's had a history of open apple shade, and it's one of probably the richest woodland in Sussex. That's where the Barbastel bat is found, which is, again, a very rare bat.
which likes deep forest. It only lives in forests that have been there for a long time, forests that are predominantly native and broadleaved, which limits it. The other woodland that you really must visit is a wood called Menz, which is, spelt as it sounds, which is just to the west of Woodborough Green on the A272. And again, that sort of population of Barbastell bats. But that's probably the nearest woodland we've got in lowland Britain to a kind of old growth woodland. You know, I said you can read the management of a woodland in the structure of the trees. That's one place where it's very difficult because it hasn't really been managed very much.
Well, thank you. Now, Louise is asking, she says, is natural regeneration better than artificial regeneration?
I'll leave that for part 2. I'll talk about that later on. So I'll come back if I don't answer the question fully, but I was going to talk about natural regeneration and planting in the next section.
A question from Isabel. She says she knows that there's a plan to produce a wildlife corridor all the way from Knepp to the sea. Do you know how the plan is progressing? And if it all goes well, do you know when this ambitious plan might be realized?
Yes, it's very exciting, isn't it? In fact, the way that's working is the owner of the Knepp estate is talking to a large number of other landowners in the area. So it's a landowner-led approach. And he's trying to make a network actually from Ashdown Forest across to Knepp and then down the Arun and the Ada valleys to the sea. So it's mainly talking to other landowners, and they've already signed a memorandum of understanding so that all of those landowners, even if they don't rewild, they are going to be doing things to try and enhance their areas for nature. So it's very exciting. It's already getting going, and there's a lot of people involved in it already. So yes, I hope we will be able to say a lot more in a year or two. So it could be the best example in England of landowners working together to enhance nature on a landscape scale.
And on a very smaller scale, gardeners can do it with each other, forming wildlife gardens through cities and things as part of the corridor.
Absolutely. Yeah.
Brian says, thank you for the super talk. Could you comment on how we can engage communities with these topics in terms of education and active roles for support recovery?
Great question. There's loads of things that can be done. I mean, the Sussex Wildlife Trust, working with the Woodland Trust and Action in Rural Sussex, are doing a project at the moment called the Lost Woods Project, which is about going out into communities in the low weald of Sussex, roughly between Lewes and Petworth, and trying to encourage people to value the woodlands that are there, to actually encourage them to do appropriate management in woods that have become neglected. And it's being incredibly successful. It needs to be very community-led, in community to recognize the value of what's in their area and engaging with it. So there are just one example of a project. But it seems to me that actually woods and trees have got a lot of purchase these days. People really like to get involved in doing things with woodland and trees.
So are you saying that are landowners generally receptive to rewilding as like shown in your drawing?
Yes. I mean, it does. It's all sorts of reactions. I'd say these days there's a lot more positiveness about rewilding than there was, say, 5 years ago. It shouldn't be seen as a threat. It's an option that a landowner could look at, is a way to look at it, to understand it. And in fact, I teach courses on rewilding at the Knepp estate, and my courses are targeted at small landowners. And there's an immense amount of interest. It's fantastic courses to be able to do. So some people will never rewild. It doesn't matter. There's plenty of other ways of doing things. But no, there is a lot of interest.
Well, thank you, Tony. Thank you very much. I think these have been fascinating questions. Perhaps you could carry on with your next part now. Thank you.
I shall carry on with part 2 and get back to that. Hang on a second. Yes, well, let's move on to the last bit now. And what I wanted to think about now is how woodlands supply benefits to us. Some of these are fairly obvious, I know, things like timber and paper and so on. But I'm not going to be talking about the more obvious things. But how are woodlands valuable to people? And if you talk about woodlands and how important they are, especially in these days of climate breakdown, a big subject we're always talking about is how important trees are in terms of locking up or sequestering carbon. We've got all this carbon in the atmosphere, you probably know. We probably should have a carbon dioxide concentration in our atmosphere of less than 350 parts per million. That's the safe limit. We mustn't go above 350. In fact, we're at about 412. We need to suck carbon out of the atmosphere. We stopped all our emissions tomorrow, we'd still have to get those levels down. So trees are often put forward as a way of actually locking up carbon, sucking it out of the atmosphere. So yeah, we talk about that, which inevitably brings us to the subject of tree planting. It gets back to the question that we've just been asked. So tree planting, should we be planting lots and lots of trees to get this carbon dioxide level down? And there's a good logic to that, because creating forests, you know, it is a way of drawing carbon out of the atmosphere and also regenerating nature. And let's go back to my original map that I showed of Europe. Our tree cover in the UK, that includes Scotland, is 13%. The tree cover in Europe, I think, averages about 60%.
Wow.
It should be perfectly possible to double this without causing any trouble at all. You know, we are in a very denuded landscape when it comes to woodland. I know the Weald of Sussex is one of the most heavily wooded parts of Britain, and yet even there are plenty of opportunities to increase our woodland cover. Here's a picture of the Lewis Plain, the Lewis area downstream, and you can see there is some woodland, but there must be plenty of opportunity to increase our woodland cover. But there is a but. You know, I was going to say there's a but, and it's not a small but. It's actually quite a big but, and that is, let's be clear, enormous ecological damage has been done in the 20th century because of tree planting. Here's one example up in the northeast of Scotland, the so-called flow country. Vast areas were ploughed and drained so that trees could be planted, because that was seen as the thing to do for timber and all sorts of things. The effect of that was it devastated the local ecology, and it caused the drying of peat and therefore emitted a large amount of carbon dioxide. So even today, that wouldn't have, you know, if we wanted to lock up carbon, planting trees in this landscape is the last thing you should have done. It's not just in the flow country of Scotland. Throughout Britain, we did enormous damage by tree planting. We think in Sussex, we lost a large extent of valuable habitat to tree planting in the 20th century, better now, in the 20th century. For example, in about 100 years, we lost 80% of our heathland. Most of that was actually down to clearance for agriculture. Nearly half of it was because of tree planting. We planted trees on heathland and destroyed the heathland habitat. And we got to a point in the 1990s, early 1990s, when we were right on the cusp of losing a large proportion of our heathland species in Sussex. In fact, we managed, you know, working with county councils, district councils, Natural England and others, it was turned around. We actually stopped the tree planting. We actually looked at regenerating heathland in heathland sites, and we avoided that loss. But it was very close to pretty much a disaster when it comes to that sort of habitat, and all sorts of other habitats as well. So I was thinking to myself, what are the major causes of damage in the last century? And mostly it was agriculture. But I'd say second was tree planting, which is sometimes a bit of a shock. We can do enormous damage by planting trees in the wrong place. And there's a few other things to think about. Think about a woodland. It locks up carbon. That's very true. It's one of the best ways of locking up carbon, but it also stores carbon. 75% of the carbon in a woodland is in the soil. Think about that. All these big trees and shrubs and plants you see, 3 times as much carbon is in the soil than is in those trees, which is amazing. And old woods continue to absorb carbon in the long term. It doesn't stop at any particular point. It slows down, but it carries on in the long term, probably because it's all going into the soil. Another thing to think about, structurally complex woodland. That means woodlands with lots of layers and lots of species and all the shrubs and trees mixed together. They hold more carbon than more simple structures. So this is interesting. I think woods that we would find inherently interesting, attractive, support wildlife, tend to be better when it comes to locking up carbon long term. So a thing we often say anyway, when it comes to the central tenets of nature conservation, looking after what we got is the first priority. Looking after what we got is the most important thing to do. We often talk about building new, and that's vital. We often talk about regenerating, rebuilding, recreating. Yes, very true. But looking after what we got is the first priority. And again, that's no great surprise. When we think about replanting, you can lose a great deal of carbon from the soils when you disturb it through the replanting. If you do quite damaging forms of ploughing in order to put new trees in, it will take decades to make up the lost carbon. You lose carbon from the soils. Yes, the trees come and they grow, but it takes decades to make up what you lost from that disturbance. Now, in fact, this picture here is actually a good example. Because if you look at this piece of machinery, big low profile tires, there's not too much ploughing, not too much disturbance, being carefully harvested. This is the sort of thing which is actually quite good. But very often you'll see heavy soil disturbance when trees are harvested, even more heavy disturbance as it's ploughed to put in new trees. That is not a good argument for actually locking up carbon. So, and shallow rooted trees also store carbon in the surface layers. So actually that means that when we do our forestry operations, you're more likely to lose the carbon that's been locked up in the soil. So it's a complex situation. The other thing to bear in mind, yes, replanting is good, but it takes a while for trees to get going. It can take up to 10 years before they start to really ramp up their sequestration, before they really get going in terms of locking up carbon. Up to 10 years. We need to solve this before 10 years. We can't wait for 10 years. Carbon rates increase with growth rate, so things get better and better. Peak sequestration, the fastest rate of sequestration, is probably it's about 100 years or so, although scientists differ in their views on that. But you have to get an idea that replanting new trees is a long-term thing, and you have to be careful about how you do it. Right tree, right place, done in the right way without too much disturbance, and it's a long-term gain. So, will tree planting save us? Well, let's have a think about that. I did a bit of a back of the fag packet calculation. 1 hectare of trees can sequester 10 tons of carbon dioxide per annum per year. So every year, a hectare can lock up 10 tons of carbon dioxide. As humans, we emit an excess of 43 billion tons per year. Okay, so do the sums. That means that we need 4.3 billion hectares to lock up all of our emissions. Great. How big is 4.3 billion hectares? I can't picture that. But it turns out it's twice the size of America and Canada added together. Actually, it's roughly the same size as all the productive land in the world. That's the productive land in the world without trees on it already. Because if it's got trees on it already, you're not adding to it. So if you think we're going to be solving our problems by just replanting trees, we're not. It'll contribute, it's important for all sorts of reasons. But what I'm saying here is that if we try to use tree planting as a reason for carrying on with business as usual, hoping that we're going to sequester all this carbon in forests, it's not going to work. Let's not get back to the question, which is great somebody raised it. Let's not just talk about tree planting. If you plant a tree, obviously in some conditions, that's a good thing to do when you want to bring in a new species and be sure of what you're going to get, be sure of the regeneration. You do tree planting. So you're in a very open area, the trees aren't going to come back naturally. So it's not that you shouldn't tree plant at all. But you're actually deciding what tree you're going to plant. You're getting it from some stock somewhere. It's a particular genetic strain. Maybe you don't have too much control on that. But think about the advantages if you actually allow trees to regenerate themselves. What actually happens is that you get species diversity. You get a mixture of trees that seed themselves in. And then there's genetic diversity as well. So you get a large amount of seeding in, but only the ones that are suitable for the site will survive. You get a selective pressure for species and individuals that are right for the site. You're not choosing which trees are there, you're allowing nature to choose for themselves. You get much more species diversity, you get much more genetic diversity. Have you been in a wood when a ash tree has set seed? You get a mass of seedlings. Now, most of those will die. They have to because there's far too many of them. But the ones that are suitable for the site will survive. And that happens every generation. So species diversity, genetic diversity, is ecosystem diversity. A very diverse ecosystem, and it's more resilient. If you get a disease, it'll respond better to that disease. If you get a changing conditions, then you've got diversity. You can actually respond to those changed conditions much better. Also, it can lock up carbon. You haven't done any ploughing there, so you haven't released carbon. It locks up carbon faster with less disturbance. So it does all those things. But one thing I want to strenuously emphasize again, our climate plan of just planting a tree, no. Tree planting is good, but if we think we're going to be able to just solve all our problems by planting the occasional token tree, it's never going to be enough. Next thing I want to talk about, there's a lot of ways that trees help us, but I thought it would be quite good just touch on water. dip our toe into water, so to speak. Trees have a function when it comes to hydrology, the way water works. Think about a wet woodland. Now, this is actually by flooding, by allowing water to stay longer on the surface, it's reducing flooding downstream. The whole idea these days is to hold water back, slow it down, so it doesn't rush into your town too quickly. The idea of holding back water is highly important. Trees in an area, it's called surface roughness. It slows that transfer of water down. Trees that are either planted or regenerated in more open conditions encourage water to percolate into the ground. If it percolates into the ground, it then goes into the aquifer. It's filtered as it goes down, so it's purified. In some of these areas, I think in the Welsh mountains, they've actually had a look at how important that percolation rate is. And I think compared with a sheep pasture, the percolation rate of water into the ground, rather than flowing off the soil, was about 20 times better when trees are planted. It encourages water to actually stay in the landscape, not rush off. And the idea of actually putting back coarse woody debris, as we call it, twigs, in other words, putting twigs and logs back into woodland, leaky dams, making leaky dams so it holds back water and encourages this diversity. Yes, it may kill a few trees. They may get flooded and actually a few trees may die. And in fact, these areas can increase the emission of methane, which is a greenhouse gas, but it provides all sorts of other benefits as well. The idea of actually putting leaky dams back into our woodland so we encourage diversity, so it breeds all sorts of habitat diversity, but it also encourages more hydrology works better. So actually the idea of building leaky dams, but wouldn't it be, I mean, this is thousands of hours of volunteer work to build leaky dams to actually get woodland to function the way they should function. Wouldn't it be nice? I wonder, wouldn't it be nice if there was something that would fit for us without us having to do this, without us having to spend all this time putting in. I wonder what it could be that we do without all that effort. Now, I can't imagine anything, can you? Anyway, so I'm kind of drawing to a close now. But when we think about all the things that woodlands do for us, storing carbon, enhancing water storage, reducing pests, genetic diversity, nutrient cycling I haven't talked about. Good woodlands produce less methane, less nitrous oxide, less ammonia, increase filtration into the aquifer. Loads and loads of positive benefits that woodlands provide. And actually the interesting thing is all of these benefits are positively linked to better wildlife. So if we see better wildlife, the odds are that these woodlands are functioning better and providing us with all these benefits. The biodiversity, wildlife, is a measure of how well the ecosystem is working. Now, all of these things are important. I won't spend too long talking about the failures of our economy, but actually all of these things are important. But actually, when it comes down to it, we often pretend they're not important. We don't bother thinking about all those things. But they're all important. Actually, a lot of these things are quantifiable. We can actually work out how much benefit we're getting from these things. They are quantifiable and real, but we don't do the sums. We don't bother. They're not quantified. A lot of these things do have a monetary value. There's a monetary value for reducing flood risk to a town downstream. So it has a monetary value. We don't bother to count it though. We just thank our lucky stars if we haven't had any flooding today. So we don't actually think about that value. We don't get its monetary value. Actually, some things, monetary value and market are different things, but some things do have a market value. Think of timber. You can actually buy and sell timber, but actually markets often fail anyway. So our economy doesn't do very well when it comes to looking at how important woodlands are, how we reflect that importance in our decision making, how we reflect that importance in policy, in the way our economy works, the way our markets work. Our economy doesn't do very well in that. And I think this is the area that is going to change in the future. So, getting right to the end now, and I'll just finish by saying, yeah, woodlands do supply us with vast amounts of what we need. Woodlands do actually support our very existence. In fact, I wouldn't just say woodlands, I wouldn't even say forest. I'd say all living ecosystems support our very existence. We wouldn't be here if it wasn't for that. So we think about that. No trees, well, we wouldn't have any timber or wood. We probably also wouldn't have any oxygen, certainly not much. about half the oxygen we breathe comes from land-based plants. The other half comes from the sea, the algae in the sea. So most of that is trees. On most of the stuff on land is trees. No trees, actually get increased pollution. Trees actually stop pollution. No tree, no woods, no trees, you get bad water management. That hydrology fails. If the water system is bad, if the water system fails, then life collapses altogether. Woodlands and other ecosystems support pollinators. We need pollinators. You don't get pollinators, you don't get any crops. And I haven't really talked about the soil. Woods lock up, 3 times as much carbon in the soil than they do in their trees. Now that's a big ecosystem in the soil. One statistic that I can't forget because it's so staggering about what a rich soil looks like. If you take a gram of soil, then in that gram of soil, that's about a spoonful, take a teaspoon. If you take a gram of soil, within that gram of soil, there will be 10 billion microbes, more microbes than there are people on Earth. There will be 10,000 species of microbes and 50 kilometers of fungal thread. 50 kilometers, that's from Linfield to Chichester, and that's a bit, isn't it? All wrapped up in a spoonful of soil. That's what a working soil looks like, and our forests and woodlands are actually very good at building soil, brown forest soils. That's what they do. So if we don't have woodlands, we don't have trees, we don't have ecosystems, we'll lose all this. And I think I'll just finish on that note. Thanks very much for listening to me, and I hope that's maybe stimulated a couple of questions.
Wow, Tony, thank you very much. The mark of a good talk is that I come away with a head that's filled with all sorts of information. Maybe I'll forget a lot of that information, but my head is also filled with a whole lot of questions. And the questions are all about the sort of the complexity of the whole thing and the timing involved. And but my big thought is the kind of the replanting. It needs lots of thought and it needs long-term planning. Now, Maggie has come up with a question as well about replanting and rewilding. She imagines you have an area that you want to rewild. So you think about the trees and you think about the ecosystem and then you plant the saplings. How does it work? How do you stop other animals kind of eating the new growth and things?
Very good question. There's a whole seminar around that, but it's a very exciting thing to do. I mean, you're right. There are 2 processes going on: trees trying to grow and animals trying to eat them, and that balance is important. So we shouldn't over-deify trees because actually some of the purpose of trees is to be eaten by animals. So yes, if you haven't got trees in the local environment, if you want to speed up that process of regeneration, then that's a rationale for planting. So you can actually get your plants in there quickly. And actually, the implication in the question is often you'll need to protect that regeneration until it gets going. But I would also look the other way. Overly dense woodland can be quite boring after a short period. So actually having a little bit of disturbance by animals coming in and roughing it all up a bit, maybe killing the odd tree, that's actually quite a good thing too. But the idea of this balance between trees trying to form forests and animals trying to make it open, that's a very good balance, and it's always shifting.
Okay, thank you very much. Now, a question from Joanne as well. She says, how might climate change affect the form of our woodlands? For example, if it gets hotter or colder, how might our woodlands change?
God, very interesting question. Yes, I mean, I used to think, and I still hold the view sometimes, that our existing mixtures of trees have got quite a wide range. So we don't need to really bring in new trees, and we shouldn't be losing too many of our own species. That's a little bit simplistic, because what we're finding is that it's not just the effect of the climate on the trees. What we're also seeing is the effect of the climate in the way it affects the pests of the trees and where they're coming from and where they're going to. So we're seeing an increase in tree diseases. You've probably all heard of ash dieback. There's other things coming along as well. And tree disease is just part of the whole mix of nature. We get too much and we're starting to lose things. That'll shift the balance. So where we might have had ash woods in the past, in future we may get sycamore woods. Now both of them live in the same climatic zone, but what's happened is we've affected the pests of those trees, and this is being seen around the world. I think there's a spruce bark beetle in America which is wiping out spruce out of a vast area because of the way climate change has affected the beetle, there's less frosts rather than the way it directly affects the tree. So I can't really answer that question very well. And my first thought is that it shouldn't change it too much. We should have plenty of diversity for our woodlands to cope. But I'm really quite worried about how it therefore affects, secondary things which will directly affect the trees, like diseases.
Yeah, and because things are so interrelated, for example, if a tree comes into flower before it usually does, because the season's changing, then the insect population might not be in sync, and so on.
Absolutely.
So all related.
Yeah, that's a worry when it comes to the blue tits again. If the tree comes into leaf early and the insects emerge early, the blue tits only hatch their eggs at the same time, and the blue tits will miss their dinner, and also the trees might be defoliated by an excess of Tortrix moth caterpillars.
Yeah, Tony, thank you so much. I think they've got one last question, and it's not to do with trees, it's more to do with badgers. It comes from Isabel, and she says, is there any news from the Sussex Wildlife Trust about badgers? Is the government going to stop making humans kill them or something? What can you tell us about badgers and the Wildlife Trust?
Yes, I don't know what the recent story is, but the Wildlife Trusts have had a campaign over a long period to say that actually culling badgers to try and prevent TB, because that's the problem. TB in cattle is thought to be spread by badgers. They've for a long time had a campaign against that. Actually, the link is weak, and also there are better ways of addressing the issue if it is an issue. So what the Wildlife Trust has been promoting is the idea that we should be inoculating badgers against TB, and if they do have any interaction with cattle, they won't pass it on. Sounds expensive, it's actually cheaper than going to all the trouble of culling badgers. So why don't we do it? Now, I don't know where we are at the moment, and from what I heard is that there's another attempt by government to carry out more culling of badgers, which is not what we agree with. So shall we put it that way? We think there are better ways of actually addressing this. I mean, you can make things a lot worse by culling badgers, because if you cull badgers, then they tend to scatter and spread. If they have got TB, they'll take it somewhere else. So actually, it's better to keep badger societies together than it is to actually spread them around. But this is an ongoing controversy, and I'm sure it'll carry on.
Thank you so much. I'm going to ask Peter to stop the recording now. So
I will, but I just thought before we do that, I just wanted to give the opportunity for everyone to give a virtual thank you to, or a physical clap to Tony for a brilliant talk.
yeah, thank you.
Thank you so much, Tony. And I will stop the recording now.
Thank you.